Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 561. Array partition. Given an integer array nums of 2n integers. Group these integers into n pairs such that the sum of the min of ai, comma bi for all I is maximized. Return the maximized sum. Okay, they are telling us to group n pairs. Group two integers into n pairs, and then they want us to find minimum among those two elements, and we want to sum all those things, and that sum should be maximized. Okay, let us see. Take this example 1432. 1432. I can take what are the possible combos. I can take 1, 4 plus 3, 2. This is my first combo. Then next combo 1, 3 plus 4, 2. This is my second combo. Then third combo 1, 2 plus 3, 4. This is my fourth combo. These are all my possibilities. So what is the minimum? Minimum here 1. What is the minimum here? 2. So it is 3. What is the minimum here? It is 1. What is the minimum here? 2, which is equal to 3. What's the minimum here? It is 1. What's the minimum here? 3, which is equal to 4, which is equal to 4. So it is my maximum. So 4 is my output. 4 is my output. So I can say among these three possibilities, I got an answer as what? 4. So whenever there is a question like all possibilities, I can say we can use greedy. We can use greedy to optimize it. Or else we can use DP, right? First of all, we want to use greedy if there is a uniformity. Else we want to use the DP. Let us use greedy first. Whether we can get the answer. So see here. First of all, this is my first example. Let us see another example so that it is more clear. What is another example? 626512. 626512. Right? Now, according to the problem, they have given this as an example, and they want us to pair like 2, 1. It is the first pair. Then the second pair is 2, 5, and third pair is 6, 6. 2, 5. Then the third pair is 6, 6. So listen carefully. We want a maximum sum. From which? From minimum of the pair. Minimum of a pair. Right? So I can say where should I get the minimum value as a maximized value? Where shall I get a minimum value of that pair in a maximized way? I can say the alternative way. That is the adjacent elements. Like if this array if I sort it, it will be like 1, 2, 2, 5, 6, 6. Right? If I take minimum of this 2, it will be 1. Right? I rather taking this 1 with 6 or 5. Why I want to spoil this maximum values? Right? I just take 1 and 2 so that my minimum will be 1, and I take 2 and 5 so that my minimum will be what? 2. And I take 6 and 6, so I got a minimum of 6, so which is equal to 9. So this is what the question states. Right? So as a conclusion, I got an approach like I want to sort all the elements in the array. First of all, we want to sort. Then we want to take the adjacent elements, because if I take this 1 and the 6, the maximum number got spoiled, right? We can use that maximum number with some other number so that I get a minimum number of those two. Here, see here, if I use the 6 with this 1, I don't get a 6 here, right? So that's why we want to use the adjacent. Fine. Okay. Now, finally, what is the time constant and space constant for this approach? Time constant will be O of n log n for sorting, and then to traversing through this whole array, it will be plus n, which is equal to O of n log n. And what is the space? For sorting, we know inbuilt function uses a merge sort. In merge sort, we consume a space of O of n, right? So space complexity is O of n. So this is my time constant and space complexity, right? Let us see the code. See here, nums dot sort of. I have already told you that just sort it. Then s is equal to 0 for I in range of 0 comma len of nums comma 2. So I am jumping by two steps ahead, right? Now s plus is equal to min of minimum number of nums of I plus nums of I plus 1. I have already told you, right, that we want to add what? Adjacent elements. We want to take a pair as adjacent elements, and we want to add the minimum of those adjacent elements in the result variable, right? So that's what this line represent. And also they have clearly stated that there are 2 into n. There are 2 into n elements, so I can make n pairs. That's why I have confidently put here like 2, and then here I put I plus 1, right? Then finally I am returning the result. Let me submit it. Yes, it is submitted successfully. So this is the approach. Thank you.